explainer. Sometimes the most familiar things hold the biggest secrets. And today we're going to take a journey down a path you think you know, but one that is just packed with infinite secrets, the number line.
Yeah, it looks simple enough, doesn't it? But here's the thing. To really get what this line is all about, we have to imagine we can capture every single point along its entire length.
So let's start our journey.
All right, here's our quest. I want you to imagine you've got this, like a magic bag. And our mission together is to walk this line and stuff every single number we find into this bag. The goal? To fill it up so completely that not a single tiny point on the number line is left behind. You think we can do it? Let's find out.
Okay, let's get into it. The first discoveries. Our journey is going to start with the most obvious numbers right there in front of us. So, as we start walking away from the center, heading to the right, we immediately start scooping up numbers. You know them 1, 2, 3, 4. The numbers you first learned to count with. We'll just keep grabbing them forever and toss them in our bag. This whole infinite collection, we call them the natural numbers, and they get the symbol N.
Okay, bag's starting to fill up, but wait a minute, let's turn back. As we look back at where we started, you realize, oh man, we missed a super important number right at the beginning. You guessed it, 0. We gotta grab 0 and put it in the bag. And just by adding that one number, our collection gets a whole new name. It's not just the naturals anymore, now we've got the whole numbers. We'll label that set with a W.
All right, 0's in the bag. Now, let's turn around and head the other way, past our starting point into negative territory. And what do we find? It's like a perfect mirror image of all the numbers we just collected. So we scoop up -1, -2, -3, and on forever. Once we throw all of those into our bag, we've got a brand new set, the integers. Fun fact, this collection is labeled with a Z, which comes from the German word Zahlen, which just means to count. Pretty cool, huh? Okay, so now our bag is getting really heavy, right? We've got all these positive and negative whole numbers, an infinite amount of them. Surely we're done now. But hang on, look closer. I mean, really look at the line. What about all that space between the numbers? Between 0 and 1, or between -2 and -3. Yeah, in all those little gaps, there's a whole nother infinity of numbers just waiting for us, the fractions. You've got 1/2, -3/4, basically any number you can write as a ratio. So let's scoop them all up and toss them in the bag. This massive new collection gives us the rational numbers, and we label them with a Q, which stands for quotient. Okay, so our bag now has all the whole numbers, positive and negative, and every single fraction you can possibly think of. Our quest has got to be complete, right? Well, this is where our little journey takes a really, really surprising turn. I mean, really think about it. With all those integers and all those fractions in our bag, is the number line finally full? It seems like it should be. Between any two fractions, no matter how close, you can always find another one. We've packed them in so tightly, there couldn't possibly be any space left. Could there? But what if I told you there are still gaps? And not just a few. What if I told you there are still infinitely many gaps on that line? It's mind-blowing, right? Even with an infinite number of fractions in our bag, the line is still full of holes. This leads to a huge question. What in the world are these hidden numbers? These mysterious things living in the gaps between all the fractions? Let's go find out. Well, they're called irrational numbers, and they are a totally different beast. Why? Because by their very definition, you cannot express them as a simple fraction. They just refuse to be pinned down by a neat little ratio of two integers. And let me tell you, people didn't just figure this out overnight. This discovery was an absolute bombshell. The ancient Greek Pythagoreans, way back around 400 BC, were the first to stumble onto them, but it took literally centuries. We're talking all the way up to the late 1700s for mathematicians to finally prove that even a number as famous as pi is irrational. I mean, this idea was so utterly shocking to the Pythagoreans, who believed the whole universe was built on simple rational numbers, that they treated it like a dangerous, forbidden secret. The legend goes that Hipparchus, the guy who might have discovered the first one, the square root of 2, was actually drowned at sea just for spilling the beans. So what do these crazy numbers even look like? Well, the square root of 2 is the classic example. So are other famous constants, like pi. Or think about any decimal that just goes on and on forever, without ever repeating a pattern.
These are the elusive, slippery numbers we've been missing, the ones we need to finally fill in all the gaps. All right, this brings us to the grand finale, the real number line. We've got our bag, which is stuffed full of rational numbers, and now we've just discovered this whole other universe of irrational numbers. It's time to put them all together. So when we finally take all those irrational numbers and pour them into our bag right alongside the rational ones, what do we get? We get the complete collection, the real numbers. We give this set the symbol R. And here's the key. Every single number on that line is either rational or irrational. Together, they make the whole thing. And this was the huge breakthrough. In the 1870s, brilliant mathematicians like Cantor and Dedekind, they proved it. They showed that this set of real numbers creates a perfect one-to-one match with the number line. What does that mean? It means there are no more gaps. None. Every single solitary point finally has a number to call its own, and every real number has its own unique spot on the line. And just like that, our journey is complete. The number line is finally full. Our quest is over. By collecting both the rational numbers and those weird irrational numbers, our bag is finally, truly full. We now have a complete, continuous, seamless map of the real number line. So the line is full. We filled every last point on this one-dimensional path. But that leaves us with one last, really provocative question, doesn't it? Does all of math live here, on this line? Or could there be other numbers out there? Totally different kinds of numbers that don't live on this line at all, existing in some other reality entirely.